Hey students, this is lesson 6.5, linear inequalities. You will learn how to graph linear inequalities in two variables and to use linear inequalities when modeling real world situations. All right, here's a review. A solution is the value or values which, when substituted for a variable, make an equation true. Determine the solution of each inequality below. Go ahead and pause here and you can check back with your answers. All right, identify solutions of a linear inequality. Is the ordered pair a solution of y is less than x plus 2? To check that, all you have to do is substitute the x value for x and the y value for y and see if it's true. So what we want to do is put 2 in for y, for a. So we're going to substitute 2 for y. And then we are going to substitute -5 for x. And we're wondering if this is true. So if we get 2 is less than -3, and that's false. So the answer is, for A, no. For B, 4, 6, so we're going to put 6 in for y. And we're going to put 4 in for x. And solve that. Simplify that, we get 6 is less than 6. Again, that's false. So B is no also. All right, go ahead and try it with this one. You can check back with the answers. All right, what is the graph of y is less than x minus 1? So there's a whole bunch of points, values for x and y that make this true. And just to give you a couple, let's say y is 2 and x is 4. 2 is less than 4 minus 1 because 4 minus 1 is 3, so 4, 2 is a solution. Another example, 5 would be less than 10 minus 1. So the point 10, 5 is a solution. And just another example, let's say y is 0. Then we could say 0 is less than 2 minus 1 because 0 is less than 1. So the point 2, 0 is a solution. Well, if I plot all these points that are solutions, including halves and all real numbers, I'm going to end up with a pattern on this graph. And the pattern will have a boundary line at the related equation, y equals x minus 1. We're going to call that the boundary line. And all of the solutions are going to be on one side of that boundary line, and I'll show you what I mean in a second. But the first thing we want to do is graph that boundary line. And if we have less than or greater than, we want to graph it with a dotted line. If it's less than or equal to or greater than or equal to, we want to graph it with a solid line. All right, since this is less than, we're going to graph the line with a dotted line. So I'm going to use the slope and the intercept to help me graph here. The slope is 1 because we have 1 times x same as x. And the y-intercept is -1 because it's -1. So I'm going to find -1 on the graph, which is right there. And then I'm going to use a slope of 1 to find other points. That means I go up 1 for every one I go over. So that would look like that. And that's my boundary line. I'm going to graph that with a dotted line. And that would look like this. All right. Now, all of my solutions, the ones I talked about earlier, are going to be on one side of the line or the other. So all I really need to do is test one point on one side of the line. If that point is true, then I'm going to shade that side of the line. If it's false, then I'm going to shade the other. And an awesome point to try is the point 0, 0, the origin. So if I take my original inequality and substitute in 0 for y and 0 for x, and then determine whether that's true or false, that'll tell me whether that's a solution and which side of the line I should shade. So I get 0 is less than -1, which is false. 0 is greater than -1. So that means 0, 0 is not a solution. So that means the side of the graph I want to shade is not on the side where that point 0, 0 is. We don't want that. That's not a solution. So I'm going to shade the other side of the line. And I'm going to need a pen to help me shade here. Let's use a highlighter. And I'm going to shade. So everything on this side of the line is a solution to that equation. And when I'm done shading, I'll just prove that it's true. I'll just pick another point. And you should always do that as a check. But so all of that is shaded, and let's just pick a random point inside there, like say this one right here, the point 4, -1. If I substitute -1 for, or 4 for x and -1 for y, I find that I get -1 is less than 3, and that is definitely true. And likewise, any other point in this shaded region will be true. So go ahead, try this. Remember that if it's less than or greater than, you're going to use a dotted line for your boundary line, and if it's less than or equal to or greater than or equal to, you're going to use a solid line. And that's to indicate that the points on the line are solution when it's solid. When it's dotted, that indicates the points on the line are not solution. So go ahead and try this next problem. You can check back with the answer. Okay, you should have noticed that the point 0, 0 is a solution. It's true, so that should be, there's that point. That should be in the shaded area, and all other points in the shaded area, including every point on the line. And just to show you that, let's try this point 2. If we do 2 is less than or equal to 1/2 times 2 plus 1, we get 2 is less than or equal to 1 plus 1, which is 2. So all those points on the line that are equal are solutions, and that's why we use the solid line. All right, so what is the graph of each inequality in the coordinate plane? What we're going to do is graph the boundary line, which in this case is x equals 2 and y equals 3. And then we're just going to shade in the direction. And one thing you might notice here as we do that is that whenever it's a less than, you shade a certain way. Whenever it's a greater than, you shade a certain way. So x is equal to 2 is a vertical line. And since it's less than 2, we're going to use a dotted line. And that vertical dotted line is right there. And now, for x is less than 2, remember that's where x is like 1, 0, -1, and so on. So that's everything to the left of the line. So we're going to shade to the left of that line. That would be everything in this region. All right, and then for y equals 3, y is a horizontal line, and it's at y equals 3. And since it's greater than or equal to 3, we're going to use a solid line for this one. And we're going to go right where y is equal to 3, right there. We want y is greater than or equal to 3. That means y is more than 3, like y is 4. That'd be like these points. Y is 5 would be these, and so on. So we're going to shade above the line. And that would look something like this. And up into greater numbers for y, greater than 3. All right, go ahead, you try that, and you can check back your answers. So there's your answers. Describe the graph of each inequality. Use the words boundary line dashed or solid. So x is less than -5. That's going to have a dotted boundary line at x equals -5, and it's going to be shaded to the left of that because it's less than. All right, and y is less than or equal to 2. That's going to have a solid boundary line. And y equals 2 is the line, and it's shaded below. All right. Next problem. Suppose you can spend no more than $20 for hot dogs and hamburgers at a picnic. Hot dogs cost $5 per package. Hamburgers cost $8 per package. What are 3 possible combinations of packages of hamburgers and hot dogs that you can buy? All right, we're going to let x equal the number of packages of hot dogs, and we're going to let y equal the number of packages of hamburger. All right, and we're going to need a graph for this. You might want to just sketch one or pause it, and you can have time to sketch that. But so we pay $5 per package for hot dogs. So 5x could represent the amount we spend on hot dogs. And we spend $8 per package on hamburgers. So 8y could be what we spend on hamburgers. And if I add those together, I can't spend any more than $20. That indicates an inequality. So that has to be less than or equal to 20. All right. Now, if I graph that, one thing I can do is use my intercepts to help graph that. My x-intercept, that's when y is equal to 0. To find that, I can just do 5x plus 8 times 0, which is this. X is equal to 4. So we're just going to solve the related equation to find that intercept. X is equal to 20, 5x is equal to 20. And if we put 0 in for x, we're finding the y-intercept, so that means 8 times y is equal to 20. And so y is equal to 20 divided by 8, which is 2.5. So there's my intercepts. Now to make a graph, I'm going to set up a scale for this. So my y-axis, I have my packages of hamburgers, and my x-axis, I have my packages of hot dogs. And I use the scale of a half on here. So my x-intercept is 4. X is 4, so I'm going to put a dot there. My y-intercept is 2.5. So I'm going to put a dot there. And since it can be less than or equal to, I'm going to use a solid line to graph this. And that's going to look like that. Put down a little better there. All right. And I have a certain domain here. I can't buy negative numbers, and I can't buy for either hamburgers or hot dogs. So I can now shade this region, and any points in that region will be solutions. So I can take a dot, like say right here, and that's a possibility. I could buy 1 package of each. Here's another place. I could buy 2 packages of hot dogs, 1 package of hamburgers. There's another spot. I could buy 1. Oh, that's a half, so I can't do that. So 1, 1. Remember, they have to be whole numbers. So then all the possibilities are in that shaded region. I'm going to pause now because I'm running out of time. There'll be a second part to this.